So, hello everyone. I'm Arthur, your host for today meetup. We are lucky to have Simon Painter here with us to talk about functional programming in C#. Simon, can you please introduce yourself to those who might not know you?
Hello, yes. So my name's Simon. I'm from the UK, as you could probably tell by my outrageous accent. I do also speak some French and German, so if anyone's having trouble understanding something I've said, please feel free to try communicating in those languages as well. I chance I'll understand you. I do my best. But I have, well, I'll go on to the next slide in a minute, but I will give a little background to who exactly I am. And for anyone that's interested, oh, can you see my mouse cursor, by the way?
Yes, we do.
Marvelous, right? That makes it easy for me to point. My Twitter and GitHub and website details are all here in the off chance that anyone actually wants to speak to me again after this. Yeah, there we go. There's briefly a little bit about me. So I've been in development for coming on 2 decades now. I've worked a whole load of different industries, mostly around the UK. I've done government, I've done retail, I've done manufacturing. I was briefly one of those contractors that your mum used to warn you about. And these days I work for Müller Dairies. I don't know, have you guys heard of Müller in Belgium or in Luxembourg? I don't know if they're well known there, but they're a dairy company. They're a German dairy company, which is great for me practicing my German. Always good. But and I have been promised free yogurt at some point, but I joined during the pandemic, so I've never really been to the office, and I'm still waiting on the free yogurt. Oh well, one day, one day. So the actual topic I'm going to talk about is functional programming in C#. So I am rather a fan of films, so I have a program of events. The slightly inaccurately named 6Ws, the who, what, where, when, why, and how of functional programming. That's roughly the sequence I'm going to go with. So first off, who is it? So these are a few folks who are significant to the history of functional programming. One of them is a software developer, and see if you can guess which one it might be. But this gentleman here is Alonzo Church. In fact, he was an American mathematician, worked a lot in the 1950s, came up with this notation for writing out functions. Now, this is all mathematics stuff, so I don't entirely understand it, but a couple of the things that are significant to us, first off, are this guy, indicating the body of the function. That's an arrow, hence arrow function. And over here, this letter here, this denotes a parameter into the function, and it's the Greek letter lambda, hence lambda expression. There we go. There we go. And this gentleman is Haskell Curry, who has no fewer than 3 programming languages named after him. This is briefly a description of what currying is, which is named after him. From a mathematician's perspective, I'll be going into that a little bit later. Now, could this gentleman possibly be our software engineer with that magnificent beard of developing? And it is. This is John McCarthy, who created arguably the first functional program in the world in the 1960s. It was called Lisp. Apparently, it still has its fans to this day. I have never used it. I don't understand anything much about it. This apparently is a block of Lisp. I couldn't tell you what it does, but there you go. They all the way back in the 60s, that was. So moving on to what is functional programming not? Before I move on to what it actually is, it's not new. So the purpose of the last few slides was to show that it's not new at all. It's actually really old. To a large extent, it predates object-oriented developing. The very beginnings of functional programming, and I once wasted a Sunday afternoon trying to look into where this sort of chain of refuted paper went back. Actually go all the way back to the late 1800s in mathematics papers. Can't pretend I understood hardly any of it, but fine. It is really old. And like I already said, it dates back in computing terms to the 60s. It's not like the latest version of Angular or whatever the latest trendy JavaScript framework is. It's really old. It's been around for a very long time, and chances are it's going to be around for an awful long time more. Not a language, a paradigm. So a paradigm is a style of programming. The metaphor I usually use is that of a guitar. If a guitar is a programming language, you may play many styles of music on the same instrument. You can play rock, or you can play pop, or country and western if you have no taste. Whatever. The point is, one instrument, many styles of playing. So it is with programming languages. C# supports many paradigms, well, at least two. Object-oriented and functional programming. And that is not a coincidence. It's a stated intent of the C# team that C# will support both paradigms. Now, this started being introduced somewhere around C#3, and every version of C# since then has consistently added more features for functional programming. And I'm not aware that there's any intention to break that pattern. I haven't quite looked at the details yet for C#8, sorry, for .NET 8, but I've got no doubt it'll probably have something in it as well. It is not imperative. So there are two, broadly speaking, there are two families of paradigms: imperative and declarative. Imperative is the family to which object-oriented development belongs. Imperative is very concerned with the precise order of operations, about literally having a little pointer that moves through your program one step after the other, and then you have loops and branching if statements and all this sort of thing to guide the pointer where to go. That is an imperative style of coding. Declarative is less interested with the order of operations. Functional programming is a declarative paradigm, and it is more concerned with simply defining the result that you want and then letting the details be the problem of the execution environment. The most common form of declarative programming most people run into is TSQL or any other flavor of SQL. Because if you think about it with SQL, the order of operations is not the order that you write in. You write the select first. It's typically one of the last things to actually be executed. Not always the last, but one of the last. And this is how functional programming works. We aren't so concerned with precisely how we achieve our results, but we're more concerned with what the result should be. And the rest of the detail isn't really important to us. Do you care that the order of operations in SQL is not the order you write? No. No reason you should. Excuse me. It is not the solution to all of your problems. It will not make the P. It will not make your kids behave and get them to school on time. But I'd argue that it'll solve an awful lot of them, at least provided that those solutions involve writing far too much code for your own good. Nor is it difficult. Folks who spent a long time very embedded in object-oriented programming tend to struggle a bit more, and I don't think that's because it is inherently difficult. I would argue there are fewer things to learn and fewer new concepts in functional programming compared to object-oriented programming. It's just that they're very different. They're very different in concept, and functional code looks very different to its object-oriented alternative. So the folks I run into that pick up functional the quickest often are university students who've not had that long career as some of us have had with entirely object-oriented code. So I would argue, despite comments to the contrary, that it is not really difficult at all, just different. So this is, we've talked enough about what it isn't. This is now, roughly speaking, what it is. Okay, declarative, I've talked about this. It is a declarative language, meaning it is less concerned with order of operations, with statements. It is more concerned with describing results and then letting the detail of that be the problem of the execution environment. It uses immutability. This means that a variable, once set, can't be changed ever, nor can any of its properties, not altered, not replaced. Everything is treated as read-only with read-only properties. If you want a metaphor for how that works, think of the working that you might give in a maths exam. You write out each line, and then you write the next line based on the previous line, and then the next line after that based on the line before, and so on. That's roughly how you might write this. So higher order functions, that is a slightly scary sounding name for something that's not actually difficult. All it means is functions which are passed around as a parameter into a function or as a return type out of one. If you have ever used func or action delegates in C#, that is exactly how we do it. So, and we do indeed use func delegates in this way to pass them around. So functions, not statements. So a statement is something which alters the flow of execution in some manner, which does not resolve to a value. So an if is a statement, a while is a statement, a for and a for each, they are statements. They do not resolve to a value, they alter the flow of execution. Those are statements. Functional programming doesn't use them, not purely functional. Now, this is C#, we can't do pure functional, it's just not the way it is. But in a pure functional environment, there are no statements. Everything pretty much is rather made of function. Functions sort of put together like Lego bricks, if you like. Referential transparency, once again, scary term, not very difficult really. What it means is that given the same values as parameters into a function, you will always get the same value back, no matter what. You put in these two values in, same result back, no matter what. No matter the life of the system, no matter the whole life of the universe, no matter what, you'll always get the same value back with these parameters in, and no side effects. That's not always entirely possible once again in C#, but we do our best. So it's also called a pure function. Recursion, I'm hoping that everybody is okay with recursion. If not, I refer you to my definition a moment ago of recursion. Carry on doing that until you get the idea. Pattern matching I used to have to explain back when I started giving this talk about 5 or 6 years ago, but these days I don't entirely. If you have used switch expressions in the more recent versions of C#, then you pretty much know what pattern matching is. And I will give example. It's stateless. You can't alter objects in functional programming. So object-oriented programming is often based around the idea that we have this state object which sort of sits in the middle of our system, and things buzz around it and periodically grab bits out, push new bits in, and so on. We can't alter anything in functional programming, so we don't have. Someone likes to joke about recursion. Thank you. Yes, so we can't do that. So what we do have state as a concept, but it's not there as a physical state object. If anyone has ever used Redux in React, that's roughly the idea. We have state as an emergent property of the system. We have a sequence of state objects, and whenever we want to make an update, we create a new instance of a state object based on the old one with some instructions and parameters to tell us how to make the change, and then discard the old one and now take the new one, and so on again and again. State exists for moments at a time, and as a concept it exists, but it emerges from the system rather than being literally this lump of stuff that sits in the middle. And well, monads, you might notice is crossed out here. That's because according to Douglas Crockford, the curse of the monad is that once you gain the ability to understand it, you lose the ability to explain it. So I shan't. And I'd also argue that it's not difficult. And hopefully at the end of this talk, everyone will agree. So where is it? Well, okay, it can be everywhere and do anything, but these are the places that you'll find it. So there's the purer functional languages, or purer, I should say. I'm not convinced that necessarily all of these languages are entirely pure, but I think Haskell is. But these are much more dedicated to the functional paradigm compared to things like C#. So you really have got to wrap side effects around with monads here, left, right, and center, that sort of thing. I don't know. I don't do these languages. I've never developed in Haskell. I may do one day. It's on my list of stuff I might do, but I'm not currently aware of anywhere near me that employs Haskell developers, so it's not high on my priorities. I have heard that folks in the banking sector use Haskell quite a bit. I have it on good authority that that's the case. I'm sure might well be. I've never had any direct experience. Although Erlang, I do hear that around. I believe that's what RabbitMQ is written in. And Elm is very influential as well. Redux in React was inspired by Elm architecture. So these are definitely not totally obscure thing that no one uses. They are out there. Hybrid languages, so like I said, C#, it is the stated intention that C# will serve both paradigms. So yes, C# a hybrid, as is Java, even Python these days. I have seen functional programming in Python as a book out on the shelves. So sure. F#, now F# is a .NET language. F# is the functional .NET language. It is not purely functional, but it is much more functional compared to C#. There's a lot of things that F# can do that C# has to be sort of mangled to be able to accomplish when it comes to the functional paradigm, but it compiles to the same intermediate language. So you can reference F# modules in C# and vice versa. So it's something you can add to an existing code base if you so wish. But it looks quite different to C#, so there would be a learning curve involved. And JavaScript, because JavaScript is everything except when it's not, except when it's an empty array, except when it's faulty, except when it's not, or something. Because it's the Wild West of programming, and it can do everything, except when it can't. I love JavaScript, but it's mad. Right. When is it? So before, I don't know if there's any more functional people than myself on the call. Before anyone starts hurling things at me, I know it can do everything. Yeah, I know it can. But there are places when it's happiest. There are places where it is certainly a more comfortable fit, and fewer workarounds are needed in order to be able to do it. Data processing. Turn data from one form to another. Functional loves that. Side effect free. Chunking data. Great at that. Concurrent systems, meaning when you have lots of things stacked up working in parallel, functional programming is stateless and relies on pure functions with a lack of side effect. And as such, it strongly supports concurrency and asynchronicity. And if you want to have lots of things running in parallel, it supports that. You tend to have fewer problems of resource contention when you don't share resources in that way. High criticality systems, functional programs tend to be more robust, less error prone compared to their object-oriented alternatives. Consequently, if you want a system to go up and stay up, functional programming is likely to be a better fit. It is a claim of some more pure functional languages that once you get these things to compile, it will stay up forever and nothing will ever bring it down. And that might well be true. We can't quite achieve that in C#, but we can get quite close. And serverless for the same sort of reason. Serverless is in effect something along the lines of a pure function. You could the functional paradigm supports things like serverless very well again. And when is it not? Well, again, I know it can do these things, but the functional paradigm relies on the idea of a pure function with no side effects. And all of these things involve side effects and unpredictability, which the functional paradigm needs steps to be taken in order to be able to handle. So UI, because that means interacting with a human being, and there is nothing more impure than a human being. External interactions with web APIs, you can have problems over HTTP, you can have network issues that will block, that's a side effect. I/O, things like file access, you could suddenly have a file that was there for an hour disappear because someone else is messing with it, or an Excel file that someone else has opened and it's blocked it. There's all sorts of things that can happen. And this is where, as I say, steps need to be taken to wrap around the side effects that could occur. Functional languages have all of their various techniques for doing this. In C#, we may just have to take the hit. Functional is never, C# is never going to be purely functional. So to some extent, it's about our task as functional C# developers is to pick and choose where it is best to be more functional and where less. That's more art than science, so I shall leave it to yourselves to ultimately choose that. But I'll try and point out some areas as we go along. So finally, why? Why should I even care? It's more concise than object-oriented coding. That is, you write a lot fewer lines of code compared to object-oriented programming, which is not nothing. If the code is more concise, that, as the next item suggests, it makes it more readable. It makes it easier to support because you don't have an awful lot of code noise that tends to come with object-oriented coding to accomplish the how of the program. You know, your loops and your branching ifs and things get in the way of trying to understand what you're actually trying to accomplish. Whereas nice, neat, concise functional style code tends to be easy to read, therefore easy to understand quickly, therefore easy to maintain, and can take a lot less time to write your changes that you need to make. It's extremely testable. Once again, referring back to the idea of purity and side effect free nature. For some people, that's one of the big draws of functional programming. You can get pretty close to 100% testability with functional. It's enabled concurrency. Talked about that before. It's more robust, and I think it's fun. I think it's fun. And I hope by the end of this talk, once again, everyone else will agree, but we'll see. So let's move on to some actual code. So this is a bit of rather definitely not functional style code. This is a bit of object-oriented style coding. So if I asked somebody to explain what this did in 5 seconds, they'd have to peer at it probably for longer than that to get a feel for it. And that's because that's the nature of object-oriented coding. It tends to obscure its meaning with all of this code structure. As it happens, what this is doing is taking a list of stories from the first season of Doctor Who. And I don't know if everyone's heard of Doctor Who, but it is the best TV series in the whole world.
Totally agree.
Is that totally or don't agree? I could be
Totally.
Yeah, it is. It really is the absolute best thing ever. And if you look in the dictionary, it literally says it right there. There may be other Doctor Who references in this talk, but so what this is doing is cycling through a bit of CSV data from the first season of Doctor Who from 1963, and then splitting by line, splitting by field, and taking out the just those ones that I personally rate as being 4 out of 5 or better. So that's removing things like the censor rights because it's frankly terrible and stuff like that, and then adding them to some sort of data run. So that's how you do it object-oriented for each and if. And here's the functional equivalent. This is an exact equivalent to the previous line. Now, if at this point somebody is going to say that looks like a whole load of link, that's because that's a whole load of link. Little secret, link is based in the functional paradigm, and that's deliberate. It is. Because if you think about the properties of functional style coding, we have things like higher order functions. So there's a higher order function right there. That's one. It's a function passed in as a parameter to another function. And we have the concept of immutability. The select statement does not alter the original array. It creates a copy based on the old one, and the old one remains unmodified. So it also supports immutability. This is entirely functional style code. And actually my goal as a functional style programmer is basically to put the whole rest of the language into LINQ in this style, this sort of nice flow of operations. Now there's all sorts of reasons why we can't do this in standard C#, which is where I've had to manhandle it a little bit to make it work better. We'll go into that in a moment. So here's another block of code for you. To give you another example of how we can save ourselves a whole load of time and effort. This is a set of rules that I used to have to work with an awful lot back when I worked for HMRC. That is the British tax folks. And this is verifying that the NINO you've just entered is valid. Now, a NINO is a national insurance number. We've all got one in the UK in order for us to be able to work. And it's got various rules. It has to have a length of 9. And here we're saying if the length is not 9, return false. It has to have certain characters at the beginning. And if it doesn't, return false. And so on and so forth. And then finally, just actually hidden off the bottom of the screen is a return true. So lots of ifs containing return falses, and then a final return true. That's very non-functional code. And here is where I could go about entirely replacing it functionally. Now I don't have to put all of these funcs stored at the top. I just like verbose code. That's optional. You could put arrow functions in here, and that is a totally legitimate way of doing it. But in brief, what I've done is I have created an array of funcs. So that is an array of functions. Each one of these is a func which turns string into bool, and the bool says this this works, this rule passes or not. So, and then we can just read it. Must have length of 9, must start with alpha, meaning alphanumeric, and so on. There's all of the various other rules. So, having put it in array, that means I can now apply link operations to my array of funcs. So the next thing I do is call all. All is a link operation, and what it says is whatever's inside here, inside this higher order function, do it for every element of the array, and all of them must return true. And if any of them return false, terminate this process early and return false. If all of them return true, then the whole thing returns true. So in terms of early false return falses and the final return true, this is an exact replica of the previous line. And what I've got in here is simply take x, which in this instance is one of these functions, and then pass in the Nino, the string, to be validated. And there we have it. This is entirely the same, but without all of that, without all those if statements. It's compacted down onto technically one line, but it's quite a long single line. And I think it's a lot more readable and a lot easier to see what has to be added. Strictly speaking, you just sort of, if you want to add in a new rule, and just press type a comma and enter here, add in an arrow function, you're good to go. Could even go a step further. Extension methods get a little bit of a bad rep, but I quite like extension methods. They have their place, they have their uses, if you're careful with them. And here I've made a generic version of this called validate, which attaches to p input. Since it's a generic, that means it attaches to everything. And this represents whatever it is that you've just called this from. And then take a params, because I'm too lazy to make an array, of funcs which turn p into bool. And then simply run the all here. This means that for my validate Nino now, I can take my Nino string, replace spaces with nothing, and then call .validate, and then just pass in a list of the rules. And this bool equals whether this string met all of the rules or not. Took me ages to explain that, not a lot of time to actually write it. This is one of the great things about functional programming. So another, what's it? Ooh, better. Another structure you could use. This is an alt. This called other things. This is a bit of a feature, I'm afraid, of the functional paradigm. There is no great big, this is the book of the functional paradigm and what all the terms are and what they mean. The concepts tend to be pretty universal, but the names are not. There seems to be no real standard on naming, so I'll try and point out other names when I'm aware of them, but there you go. So alt means I'm going to give you several alternative ways of getting the same data, try them one after the other until one of them works. So I've got two entirely hypothetical database operations, one that works and one that returns null. Now, these, of course, are represented by func delegates up here. In the real world, these will probably be calls to interfaces or something of that sort. And I'll take my input, which is, hey, my name, and alt says, try this one, the one that, as it happens, we know doesn't return because it's a false. Then try this one if that didn't work, and that will actually get some value back. And this works fine. What it means is that you specify 2 different steps, and the structure of the alt decides how many of these different steps to execute and what finally to return to you. Now, this is how it happens behind the scenes. There's all sorts of other ways you could do this, but this is how I did it. So first, alt, which attaches to a t input, that being everything, and we've got a t output because we're changing type 1 to type 2, whatever they might be. In my case, I was going from string to string, so that was pretty simple. And I've got my first function and my second function here. You could even do this with an array of functions if you want. Not entirely sure how that would work. You'd probably actually have to put a while loop in there. Run function 1, and then off that call if default do, which is another extension method I made down here. If default do says run an equality comparer. That is a generic way of doing a null check. You can't do a null check against a generic because you don't know whether or not it's actually a nullable value. There are many data items in C# which do not default to null and can't be null, like integer or Boolean and various others. So this is the generic way of saying effectively null check. So what I'm saying is, if the value of this equals default, that is often null, not always, then run the else function and return its result. Otherwise, don't run the else function and simply return whatever this is unmodified. It's sort of like a gatekeeper function that sits between the input and the output and decides whether to get it involved and change and do something or just to let it pass. And that's how that works. So another data structure here. This is a fork. So this is a ridiculous example because I just wanted to keep it simple. I don't want to get too bogged down in the business logic of any particular case. So I'm saying I've got an input string. Now a fork and a fork works by start with a single input, split it into various prongs of your fork, and then perform some sort of operation independently on the prongs. As in, the prongs each have the same input, which is the original input, and then they each evaluate to something else, which is then presented in an array form to a joining function, which sticks them back together again into a final result. So one thing to many things to one thing again. That's a fork. And in my case, what I'm doing is saying, start with this string. These are my prongs here. Each of them performs a count operation and returns a count of a different value of character. So these is a count of all the A's, which is 3 as it happens, count of all the B's, also 3, count of all the C's, wouldn't you know it, also 3. So this is the join function here, and it just calls sum. So I'm going to take 3, 3, 3, and it's going to end up as 9. Now you'd never really do that in the real world, but I'm just demonstrating in as simple a manner as I can think of how we go one thing, many things, back to one. And how does the fork work? Here it is, behind the scenes. First off, we've got something called map. Now, map here doesn't work like, I think the map in JavaScript works very like the select in C#. This is not that sort of map. JavaScript uses map a little differently to the way some functional environments work. Map is similar to a select in that it converts from thing A to thing B, but unlike select, it operates on the entire object. A select, which I think is technically a fold in functional programming terminology, a select works by running a particular function against each element of an array individually. So take this function, element 1, stuff it in there, element 2, stuff it in there, and so on. Whereas a map takes the whole thing and runs a function against the whole thing. So if you call map of an array, then X in your arrow function is the whole array, not an individual element. If it's a string, if you call it off a string, then X is a string, and so on. It's the whole object. It is different to a select or JavaScript style map. So that's all that is. But otherwise, it's the same concept of I'm effectively doing an arrow function to convert old version to new. It just saves me having to store a temporary variable or nest the functions in strange ways. So what I do is here in the fork itself is take the prongs, which is a params of t funcs that turn t input into t output, and call select. That is actually my link select. And then inside each, I'll say run the function against whatever the original input was, which is up here, and then call map, which is converted into something else. So map operates on the whole thing. So actually the output of the select is an enumerable of the output, which in my example before was integers, and passes that into the join function. And the join function is something which takes an enumerable of outputs and replaces it here with a single output. Now, I have created more complicated forks than this in the past, where there are intermediate steps of, intermediate types, that the prongs go from type 1 to type 2, and then the join goes from type 2 to type 3, and so on. You can go as complicated as you like with this, but this is a simple example. I'm keeping it simple just to show you the concept. So moving on to pattern recognition, pattern matching. Always making that mistake. Pattern matching, different to pattern recognition. Pattern matching. So this is the standard set of kind of the types of classes everyone seems to use whenever we want to talk about inheritance and polymorphism, bank accounts, for whatever reason. So fine, I'll use bank accounts. Let's start with a standard bank account, which has a balance and an interest, a super duper bank account for our special customers, which has got a bonus interest rate, and then finally a dodgy bank account, which has got a brown paper bag of money, presumably picked up in a car park. At this point, I would often encourage everyone to laugh at the foolishness of a politician who's behaved badly in the newspapers, but I don't know, these days it feels like you take your pick. So just choose the politician you care to name and they can go in there. And this is how pattern matching works, at least in C#. So here I'm passing in actually the base type, which is bank account. And then I am casing inside this switch on the actual type, not the base type, but the actual type. And that, if that matches, if, for example, this BA is actually a dodgy bank account, then this case will hit and it will automatically be wrapped into this local variable, which is of the correct type, without any sort of casing error, because we know it's that type because this case hit. And then inside that, you can reference the type without any sort of problem. And same here. And you can even reference properties. So standard bank account here, I've got two different rules attached to it. One when the balance is less than 10,000 whatevers, and another one finally when it's clearly over that, where we're going to apply some sort of special bonus interest rate or something. And imagine just how much code I'd have to write to do all of that if I didn't use a switch expression. It'd be quite a lot more. Now, later versions of C# have improved this quite a lot. This has been one of the areas of much more recent progress compared to some of the other functional features of C#. So now we have this nice sort of JSON style syntax where you can match on the properties of your properties of the object, and then, but other than that, it's still the same principle. Immutability. One question I sometimes get asked is, can we do immutability in C#? Well, the short answer is no-ish. The long answer is yeah, kind of. So this is an example of something that's pretty much immutable. Okay, I've got this class, I shall call it immutable1, and it has property A and property B. It has no setters, and I'm setting them here in the constructor, which I am forcing the outside world to provide. So this class and its properties can't be changed. That's fine. That's immutable, I believe. But how about now? Is this immutable? I am not allowing anybody to set a new instance of type C to replace the old one. But the problem is that it's an I list, and the I list can't be replaced, but you can still add and subtract items from it. You can still change it. So this is not immutable. This is again. So now I've got an immutable array. Okay, that's marvelous. That means that the array can't be altered now. So great, we are suddenly functional once again. Great stuff. How about now? Subclass. I don't even know what's in the subclass. Now, of course, I do in this instance because I made this up. But in the real world, you don't really know what's in the subclass, whether it's got mutable or immutable properties or whatever. We don't know, and that's the problem. And it's not just your code base. I mean, it could be that this subclass is part of your code base and you are in charge of code review and you've ensured that it's all immutable, and that's super duper. But then what about when you have to include something that comes from NuGet? You absolutely cannot guarantee that anything that comes out of NuGet or out of the deeper recesses of the .NET framework, you can't ever be sure that any of that is immutable. It's always going to be. Always going to be. Now, there are all sorts of ways of dealing with this, but not everybody likes me for saying this. My answer is simply to pretend that everything is immutable. Now, once in a while, something will pop up where you've got no choice. I mean, not long ago, I worked with the SMTP module in .NET, and that is really quite clunky and old-fashioned, and there's only one way of doing that. But for the most part, just pretending everything is immutable works fine for me. It's not perfect. It's not enforced by my execution environment, but it works. I actually can write pretty reasonable code. I mean, I have made use of the init. I think I'll show it in a minute, but the init setter I quite like. I use that. But we have got this as well that we can add in now. We can add a tag that's a nullable as enabled. That gives us something, not nothing. It's just moaning if you ever try to make something null. That's pretty good. I don't use it, frankly, but yeah, we could do that. That's a thing that they've added for us if you want to try and encourage people down this way. I think I heard tell that as of C#8, this might actually go from a warning, which is what it is at the moment, to a break the build matter. I don't know if that's true, but that's what I heard. If anyone can correct the record, let me know. And this it means that you'll get warnings if you try and do something like this, where this value could be a value or null, and it's now moaning and saying you're not really supposed to make things null, because once it's null, you can't unnull it if it's immutable. If you really do want something to be null, because I'm a grown-up and I know what I'm doing once in a while, then you can use the exclamation mark to override it, and that gets rid of this sort of stuff. But I'm not sure why you'd ever do that. You could also, and you can tell how old this particular slide is now, but you can also set it at the project level too, if that's what you want to do. And yeah, you can. It's there. It is a feature they provided for us relatively recently, but I don't use it. I do use this though. This is the init setter. So init is an alternative to set, and it means that you may change the value of this property during construction like this, during your anonymous constructor, and then subsequently you can't change it. It doesn't protect the property. So again, with my iList example, your iList will still be in, you can still interact with that and change it. But this is pretty good, and this will break the build if you try and change prop2 after setting it here. So I like this, and this I use basically, unless there's a really good reason, I always use init rather than set now as my setter. Another thing we've had recently, which is my favorite thing in C#, it's my other favorite things that they added for functional programming, is record types. I love record types. As of now, I believe they're actually disguised objects, and I think there's plans in place to change that so that there's an alternative version, which is actually a struct. But for now, at least, they're disguised objects. But the nice thing about them is that it gives you a facility to make a replica of an object with a change. So this funny little code sample I threw together takes an enum, and then based on which enum value you pass in, it tells you which of these properties to update based on a string input parameter. And yeah, this is really nice. Because like I said, the way of dealing with state in functional programming is that we create a new state object based on the old. And if we don't have record types, that's a pain, because it means that you've got to literally list every single property every time you create a new state object. And this means that we don't have to anymore. You don't have to go back and update it when you add a new property and stuff like that. This is really nice, and it's a very, very useful feature that I literally use all the time. So currying. I talked about currying earlier, and I'm going to show you whether or not we can do it in C#. It has nothing, incidentally, to do with delicious, delicious Indian food. It has everything to do with Haskell Curry, who is the gentleman credited with it, although strictly speaking, I don't think he did invent it. I think it was a guy called Moses Schoenfinkel, something like that, but Schoenfinkeling doesn't sound anywhere near as interesting as currying. So what actually is currying first? So let's imagine for a moment that I've got myself a function here. Now this is a function that takes an int and turns them into another int, as in it adds. It's an add function. Fine. Okay. In C#, that is pretty much like give this a 10 and a 20, you get back a 30. That's fine. Now, what if this was hypothetically a language where we could do currying and I added only a single parameter? What would I get back? And I haven't got an operator overload. It's a 2-parameter function. I don't know whether, but I'd normally ask the audience to reply at this point, but I'll probably give the answer myself. There is a rule of thumb in functional programming. If you have a question, the answer is functions. And that mostly holds true. So if you could curry in C#, which we can't, but if you could, and you gave a 2-parameter function a single parameter, you would get back a function which references the original function, the 2-parameter version, but now the new version has only a single parameter, which is the parameter you did not apply. So by giving add a 10, what you have done is turn a 2-parameter function into a single parameter function, which now adds 10 to whatever you give it. The 10 has now been filled in for you. Now, the original function is unchanged and as it was, but now if you reference it through this answer2 version, the 10 will always be filled in. Now, you probably wouldn't do it in this rather silly example. And also, if you give answer2 the second parameter and give it the 20, then yeah, it'll actually collapse into an actual value rather than another function. So this is how one way you could do currying in C#. Notice here there are 2 arrows. There's an arrow here and there's an arrow here. These are arrow functions which generate new arrow functions. Effectively, they're like factories for making funcs. The return type, notice, is func int. So when you supply this x here, let's say 10, then what you return is this bit here, where x now is filled in with 10, and y is the second parameter, which is also an integer, which will be filled in later, and the same for the rest. So I do use stuff like this sometimes, and it exists, and it's a thing you can do, and I present it to you here, but this is one way you might do currying. This is another way. Now, strictly speaking, what I'm about to show you is not currying. There are 2 concepts which are often confused with each other. There is currying and partial application. Roughly the same idea, but with currying, you strictly apply parameters 1 at a time every time you call the function. With partial application, as here, you could apply multiple parameters at the same time. So returning to Doctor Who, the source of all light and joy and happiness in the world, I am going to create here a single func, which will take my CSV, split it by line using new line, split it by field, which is commas, and then take out the specified field that you are interested in. So it has 4 parameters. The first is whatever it is that denotes the split between records, which is a new line in my case. The second is what denotes the split between fields, which is a comma in my case. The third is using a 0-based array, which item out of that do you actually want to get? So either this column, or the last column. And D is actually the string that I'm going to convert from a single string into this list of data. An enumerable of strings, whatever it is you want. Okay, and I'm going to apply some partial application to this to make multiple versions of this same function, but without changing the original. So whatever I do from this point on, the original function here will not change and remains as written. So here's some partial application. So for the time being, I have made a magical partial application extension method called apply. We'll go into how it works later, but it basically works on the principle of supply some parameters, get a func back, or else get a result back. Okay, so first off, here's my original data. I'm going to call the parse and partially apply it into by giving it 2 parameters, /r/n, that's a new line, and comma. So this means I now have something called parse, which is a function which has 2 parameters now, because there were 4 in the original, now there are 2. And the split by new line and split by comma are now filled in. This takes an integer, which is which field do you want, and a string, which is the final string. So if I call this parse and partially apply with a single integer value 0, giving me the 0th item out of the data set for each line, which as it happens is the serial code of the episode, then what I've got now is a function which takes a single string parameter, that's this, and will parse it, split it by record, split it by field, and then take the 0th position item out of it. So I get back an array of story code. And here I'll call partial apply again, but this time I'll reference back to parse, but instead of a 0, I'll give it a 1. This is now a function which takes this mass string, splits by line, splits by field, and then takes the 1th position item, which is the story name. So I've created two different versions of a parser. One which parses it and gets the story codes out, one that parses it and gets out the story names. But I've still only written one function. That's how you can use partial application. You can create many, what appears to be many functions, but without actually altering a single base function. This is how it works behind the scenes. Now, this is, I'm not going to lie, pretty ugly. And it's got some limitations. For a start, it attaches to funcs. So you can't pull apply on functions. The function has to be stored in a func delegate, and then you can partially apply the func delegate. You can't partially apply a function. Go into the F# world, you absolutely can. In F#, currying works out the box. It's just a feature of F#. C# it's not. So we have to make do. And the other thing is that this turns funcs to funcs. And if you see here, I have referenced the func with these many parameters going in, and then these many going out. So this is turning a 4-parameter function to a 2. What I have got to do is to create a version of this apply for every combination of how many parameters in versus how many going out. So I might have to create dozens or hundreds of these things in order to satisfy every possible combination of how many functions, how many parameters to how many. Now, do you really want to go through this pain? Your choice. It is a technique which I'm presenting to you, and it is your wish. If you use it or not, it does work. It is just fine. Here it is. But it does mean that you've got to have somewhere at the back of your code base a whole library full of these things, these applies. So I'll leave it to you whether you think it's a good idea or not. So moving on to the last stage of a functional flow. So this is a typical functional flow. Start with one thing, split it into many things first opportunity you get, because functional works very like SQL in that it effectively works by applying list operations, the list level for things. And then let's filter it with a where. Let's select it into a new type with a select. And then finally, this is the last bit, aggregate. Aggregate is the art of turning many things into a single thing. So this will usually be the last bit where you've done all of your data chunking, and now you actually want a final answer to whatever your query was at the end. And that's what aggregate is. There's a few methods of doing this in C#, and strictly speaking, these have been around since about C#3, but I shall carry on talking about them until it becomes clear that finally everyone's heard of it. So this is a very object-oriented way of aggregating. I want to aggregate my story title from Doctor Who into a nice list with new lines and commas. So we'll make a string builder because yes, I'm aware of the thing with concatenating strings. Loop around my array of items, take the item I want, append the story, and check whether we're at the end, because you have to apply a comma to all except the last item, because otherwise it's grammatically incorrect. And that's a lot of code to do something that could be done like that. Okay, this is me being slightly facetious, but I do love string.join. String.join is awesome, and if anyone doesn't know about string.join, learn about string.join because it's one of the best features of C#, aside from all the. But yeah, string.join will automatically put the correct filler in between those and merge it into a single string for you. But that's one of the preset versions of aggregation. There are some others. So let's take a set of story data from Doctor Who to give you some example of some of the others. So I have made a slightly more complicated data structure here. A code being the story code, the title of the story, the rating according to me and whether I think it's good or not, the number of episodes, because in the old days, every single story of Doctor Who was a serial with multiple episodes, and the number of missing episodes, because there are 97 missing episodes of Doctor Who. And if anyone on this call happens to have any of those, please hand them over. I'd quite like to see them again, especially if you've got Fury from the Deep. That one looks pretty good. So let's make some data based on this. So there's the out of the box link aggregate methods. So this is sum. We've seen sum already this talk. Sum means says give me a higher order function that selects out something that ends up evaluating to a numeric of some kind, and then add them all together. So this will give me a total number of the episodes. This one will give me a total number of the existing episodes by doing number of episodes subtract number of missing. This will give me an average because they called it average. Strictly speaking, this is a mean. I don't think the other forms of average are supported by link out of the box. Certainly, I'm not aware of any method to calculate medians, but fine. And that's the average rating Those are simple out of the box aggregations, but there is the grown-up version, and it astonishes me how many people don't know about this one. But this is the full whack make your own aggregation function, and this has been in LINQ quite a long time, and this is an amazingly powerful tool if you're not aware of it. So what this is saying is it works a bit like a select, except gradually we are converting our array of items into a single one. That's the difference. Select goes from array to array. This goes from array to single item. So we have a first parameter is a kind of like a state object. This is the state, the running progress of our aggregation so far. I am going for a tuple, which will contain the total number of missing on one side and the total overall episodes on the other side. This is our initial state of our aggregation, which is 0 and 0 because we've done nothing to it. And then after that, you have to pass it a higher order function, which takes two parameters: the accumulator, which is the running total so far, and the current item. This is just like your X in a select statement. This represents the current item from the array. And from this, you return an updated total based on the previous one. So this represents the previous. So starting then, let's run through the episodes and give you an example of how this will work. So we start with 0, 0. So the first time this triggers, ACK is 0, 0 because that is literally it there. And this is the current item, which is the first story in the array, which is an unearthly child, which has 4 episodes and none of which are missing. So this will be 4 here and 0 here. So that will then return a new tuple with 0 and 4. That means that this now, second time it executes, now has 4, 0 in it. So it executes again for the second story, which is the Daleks, which is 7 existing episodes and none missing. So now the new item is equal to the previous totals plus the new ones. So it will return a new tuple containing 4 plus 7. Oh dear, my mental arithmetic is shocking. 4, 7, 8, 9, 10, 11, 11, 0, and so on. And every time this executes on an item from the array, it returns a new total. And then the final object that comes out of this whole thing is a tuple containing the total missing episodes and the total overall episodes, from which you can then do some statistics. And yeah, there are 21% of this particular series is missing, which is rather sad. So moving on to my last idea I'm going to introduce to you. So I'm British, as you no doubt can tell by this point, and it is a cliche that British people like to talk about the weather. Well, it is entirely true. Our weather is, shall we say, unpredictable. We probably get the same amount of rainfall as an awful lot of other countries, but we get it in random order. Unlike places like India, where my wife is from, where they know roughly when the rain will come. In the UK, it could come at any time, anywhere. It is sometimes said that we can get 4 seasons in a single day, and that's not far off. So I used to work for an American company, and being British, one of the things I would do is say, how is the weather? And they would say things like, it's 100 degrees outside. And I would say 100 degrees. Well, goodness me, sounds suspiciously like the boiling point of water. That sounds like you should all be screaming and dying and bursting all over them. But no, they are, of course, working in Fahrenheit, which is used in the US to measure temperature. And I work in Celsius, which is used everywhere else. And this then is the formula to work out the conversion between Fahrenheit and Celsius. It's deduct 32, multiply by 5, divide by 9. Yeah, of course it is. And then I'll do a math.round to make it 2 decimal places to make it look a bit friendlier, and then perhaps append a degree C on the end. So what I have got here is a series of operations. I'm like a relay race of values. Each one is performing an operation, and then whatever that result is, passing it to another, to another, to another. Now, this is not functional because here I'm doing it by literally altering the original value as often as I can, up until the point where it becomes obvious I can no longer do that because we're converting to string, in which case we'll move to a string. So this is not functional. This is not immutable. I could create some little local variables, like return var a equals this, var b equals that minus 32, and so on. But what's the point? Why create these little local variables when I'm just going to chuck them away the moment I've used them? And those things remain in state for as long as you reference the function. If your function is long, that's staying in state the whole time, in scope the whole time. So this is a functional way of dealing with that. So this is a structure, which I'll call identity for the time being, an identity of T. So by making, and what this is a box. It's a box with a thing inside it. Because I've said identity T, that means that T is a generic. So it could be anything. Anything could be in this box. I don't know. Could be an integer, could be a class. I don't know. But there's a thing in the box. And value is the way I've referenced the thing in the box. Bit of syntactic sugar, so I don't have to bother saying this equals this. But other than that, it is fundamentally just as simple as that, thing in a box. Made a new extension method called toIdentity, which is basically a function which take this thing and put it in a box. Now it's the thing in the box. And then finally, bind. Bind works like my map type function earlier, which takes attaches to an identity. And once we've attached an identity, we can call bind and pass it in a function. And the function turns the old one into the new one. So what this function does is take my old box, pull the value out, run it through the function so it's turned into something else, and then put it in a new box and send it on its way. That's what that does. It's like I said, it's like a relay race. Imagine a relay race where the baton is being passed from runner to runner, and each runner here representing an operation being carried out on whatever the previous type was. This is where my metaphor falls apart because the baton doesn't change, but fine. Okay, and it means I can rewrite my Fahrenheit to Celsius like this. Look, these are my curried types, by the way. I found they're useful. So what it means is take my input, turn it into an identity that is now a decimal in a box, and then call bind. And what bind says is, here's a function which, as it happens, because this is a curried subtract, means subtract 32 is actually a function which takes the value and subtract 32, and that's a function that takes the value multiplied by 5, and so on each way. So each step here is a function. I can just pass an arrow if I prefer to do the math.round or to do the string. Each function is carrying out an operation on what was passed to it, and then passing it on to the next person. This is the simplest example possible of a monad. In case anyone ever wanted to know what on earth one was, this is what a monad is. This is what it does. Do not, I repeat, do not look up any formal definitions of the things on Wikipedia. Those things are impossible even for me to understand, and I've been working with monad for years. But this is really what they are. It's a chain of functions. There's a little more to it, which I'll go into in a second, but that is in essence what it is. A chain of functions, each one doing something and then passing on to the next item in the chain. Now, this is the simplest one. All identity does is just blindly say, I'll run the function, here you go. But that could have problems if you're starting to tap into things like external dependencies and stuff like that. This is where our next item comes in. This is a slightly improved, as it were, monad. This is the maybe. So maybe is another kind of monad, but it has a difference. Unlike identity, identity just simply says, like, whatever you say, I'll do it, and I'll trust that everything works, and it's all good. Maybe is a little more suspicious about what you're passing to it, and may or may not actually execute your function. So first off, I'm taking person ID, which is 12 for some arbitrary reason, and I'm using that to call a get person to. Now this is a function of some kind. Who knows what it is, and it doesn't really matter. Maybe it's a database lookup. Maybe it's a flat file lookup. It doesn't matter. Whatever it is. But the point is, though, that because it's a data lookup, it might work or it might not. Maybe person 12 exists, or maybe this is null. I don't know. If person 2 exists and the data is all filled in, then this is all fine. Now, what this is actually doing is, because I am very cool, it's converting the name into leet speak. So swapping A's for 4s, E's for 3s, I's for 1s, and O's for 0s. So presumably also wearing my cap on backwards and wearing a pair of nice sunglasses and all this, because I'm cool and this is what cool people do. But if on the other hand, and person 12 doesn't exist, if this returns a null, then this, unless we take steps, is going to throw a null reference exception, because that's what happens if you try and reference something that's null. But this actually won't This is inside a maybe, and a maybe handles that problem for you. Okay, I'll show you how. First off, this is a simple example of something called a discriminated union, which is, the idea is that you've got a single thing which will be one of two or more states, and you don't actually know which one. It's kind of like Schrodinger's type. Okay, Schrodinger's type. Imagine that we have this sort of base abstract class cat, and then you inherit off it twice, a live cat and dead cat. And until you run something like a switch expression to check whether it's a live cat or dead cat, you don't actually know. You just know it's an example of base type. So more pure functional languages have got ways of doing this built in. F# does, but in C# we have to replicate it as best we can. And my method is to take an abstract class of maybe t, which is basically the same as an identity from before, and inheriting off it twice. Once called just, which is basically an identity containing a value, or once again with called nothing. And this represents that there was nothing inside the previous value, as in it was a null. Okay, so this maybe represents two states of being. There's a value or there's no value. Then here is a slightly more complicated version of the bind. Same parameters in, so the maybe, which is the same like an identity, it's a thing in a box, and the func, which turns the old type into the new type, wrapped into a new maybe. And we'll do a switch expression, and I will case on, as is, I will select base start here on, it was a something handed to me, and the value that it contains is not null. So that means that for this to trigger, the previous step had to have worked, and it actually contained a value and not simply a null. If that's the case, then execute the function passed here and return it inside a new maybe. If, on the other hand, the previous step was null inside the maybe, or it was a nothing, or an exception occurs trying to run this function, in all of those cases, return nothing, return a new nothing. And that means that when the next step comes around, it will fail this check and then simply it'll return a new nothing. So what that means is, I go here, let's imagine for a moment that get person 2 return null. That means this bind behind the scenes will say, okay, it was a something, it was a just. Let's have a look inside the box. Oh, that's null. You know what? I am not going to execute this function. I'm just going to return a new nothing. This function remains unexecuted. Same here. This function and this function, they are not executed. The only functions executed in the event of a null occurring is this one and nothing else. The best description I've ever heard of this process was from Scott Balashin on his website, F# Fun and Profit, very good website. And he describes it as railway-oriented architecture. And the idea is that you have two railway tracks in parallel. The happy path where everything works, where there is something and something and something, and then the unhappy path, which is nothing. And every function call is like a set of points. And if at any point any of those functions result in an exception or a null or whatever, then we switch paths from the happy path at the top, where we're executing functions, down to the unhappy path, the nothing path, which simply glides into the station at the end without executing another function. Otherwise, if we didn't do that, we would have to surround all of this code with try catches and null checks for every operation. And if you're doing a few, I mean, I'm only doing one operation, so this wouldn't be too bad. But what if you're doing 2 or 3 different operations inside this? Then the result of that would be that this relatively simple little block of code gets surrounded by an awful lot of code noise that's just there to protect you against the possibilities of null and exceptions occurring. Whereas this monad style bind system, this does it all for you. If you use this system, it's going to be incredibly hard for you ever to have an unhandled exception ever again, because the bind handles it inside for you. There is another form of this that you can have. This is either. It has a left and a right. not entirely arbitrary. I think the left hand is considered evil in many cultures, and the right hand good. The word for left in Latin is literally sinister. Sinister actually means left-handed. And in fact, dexterous literally means right-handed. Right in Latin is dexter. So, but what this means is that the right-hand path represents good, and the left-hand path evil, or rather an exception. And in this case, it's slightly modified in that the right again operates just like an identity, but on the left-hand path, I assume that an exception occurred. And not only do I have the fact that it's a left here to tell me that something happened, but also the exception is contained within the left object, which means that if I do a switch expression on the other side, I can do a switch to say, was it a right, in which case right back to the user that everything worked, or was it a left, in which case right that it didn't work, and also here's some details of the exception that occurred inside. And here is the slightly more complicated version of the bind again. This time it's whether we return a new right up here, or in all other cases, return a left. Now, in my daily coding, I actually merge both of these into one. I have a 3-state monad left, which I call it maybe for the sake of it, and it has 3 states: something, nothing, and error. So the nothing representing that nothing errored, but also nothing was found. It's a null. And then error to say it not only didn't find a value, but an error occurred, and that needs to be handled, because I consider those 3 to be different states. There's no rule. I do what I like, but you can do as you please or not. And question I often get asked is, are there any pre-built NuGet packages that do all this for you? Yes, there certainly are. LanguageX is probably one of the best ones of those. There are others. I quite like one of, which provides you with discriminated union. That's quite nice. So there are a few other libraries out there. LanguageX is probably the richest and most detailed of all of these. But personally, I actually don't have an issue with just implementing my own. As you can see, none of the code I've written as part of this talk really took an awful lot of time to write. None of it's more than a few lines of code in most cases, so I don't see an issue with just writing your own personally, but it's up to you. I am non-prescriptive, so do as you like, and I'm not going to criticize you. This is what my Fahrenheit to Celsius conversions look like in LanguageX. Roughly the same, but it uses map, and at the end you have to call a match to collapse the monad from a possible 2-state into a single state. So one of these represents the fact that something came out of it, and the other that nothing came out of it. And you've got to decide at that point how to handle this situation. Is that better or worse? I don't know, but this is how it handles it. But other than that, it's roughly the same. So places that you could go for further reading. Well, there is a book by Enrico Buonanno, published by Manning, second edition now available. That's very good. Functional Programming in C#. That is one of the books that put me on the path in the first place towards functional programming. It is an excellent book. There's one published by Pact by, I'm hoping I'm saying this right, Visno Angoro. That one's good, but it's not. I like the Buonanno book a lot more. I have to give mention of Kathleen Dollard's talk, Functional C#, which was presented at NDC Oslo several years ago, and I was present in that talk, and that is actually the original incident that inspired me to get interested in functional programming in the first place. So if you could magically somehow turn the camera around, you would see me in the audience go, oh, wow, this is so cool, like that. There are a couple of talks on Pluralsight. I think they're a little out of date now. I hear tell that Pluralsight might be modernizing some of these. I don't know. I have not got any inside information, but they do exist. You could go looking at F# for Fun and Profit, Scott Lashin's website. It is not just for F# developers. There's some very good articles on this website about functional theory. It is at the very minimum worth tracking down his article on railway-oriented architecture. That's a very good article. And finally, if you want to go all the way, there's something like Learn Your Haskell for Great Good. Go all the way. That's a pure functional language. It's functional or nothing, if that's the way that you want to go, and that's why not? Although that's further than I've ever gone. So finally, I have a book coming out soon too. I was approached by O'Reilly about a year or so back, based on some of these talks and articles I write, and they asked if I would not mind writing a book for them, and I said, sure, I'll do it. Why not? It's been about a year and a half so far of work, and we are just about coming to the end now. I'm hoping that this will be in the shop in September at this rate. It is available for early release at the moment, so O'Reilly have provided me this barcode, which feel free to scan. It will give you a few months free on their platform, and you can read, I think there's about 12 chapters available of the book right now. It's still being edited, although it is getting to the point that it's slowly converging on what might be its final form. It is also very silly. Oh, and as of just a month or so back, they finally announced what my actual animal is, because every O'Reilly book has an animal on the front. This is not my animal. This is the early release animal that everyone gets. And they obviously thought that being British, I would fully appreciate a coyote, which is a dog-like creature that lives exclusively in the Americas, and I would like to ever see in my life. But fine, it is my coyote, and I love him very much. But this is the final cover of my book, and hopefully it will be available soon. I'm certainly looking forward to getting a big box of authored copies when that finally happens. It's on Amazon and all the rest of those retailers, and I dare say it'll be available in the shops at some point. I don't know. But there we go. Feel free otherwise to follow me on Twitter and the like if you want to hear the latest news on that. Cool. Well, that is it from me in terms of slides and stuff. Does anybody at this point have any questions? I'll give you a couple of seconds. I sense a bit of awed silence here. But,
if no one have any question, I do have one.
Okay.
What is your take about performance in the functional paradigm?
The what? I'm so sorry.
The performance, like
Oh, there's always.
you know, if you get a great deal of requests, is it a good paradigm?
Okay, performance, and this is something that comes up far more often than probably you'd realize. It comes up quite a lot. Is there an issue with performance in C#? Yes, with functional code, that is. There is. In C# is not optimized for functional programming. Generally speaking, functional code style code in C# will be less efficient than the object-oriented alternative. That said, first off, nothing's going to stop you from writing bad code. You write it functionally, you write object-oriented. You wrote bad code, you wrote bad code. Nothing's saving you from that. But the amount of difference is fractional compared to the difference that, say, throwing in a database operation or throwing in a file read operation. Compared to the amount of extra processing effort involved with throwing something like that in, the amount of the performance difference between functional and non is fractional. Even if it weren't, I would argue that the gain you get is largely in, first off, functional code tends to be faster to develop than object-oriented alternatives, it's more concise. It is also less error prone. So you tend to spend a lot less time in production trying to work out what went wrong and where. And because of that, I would argue it actually saves quite a lot of money. It's saving a huge amount of time in developer time, in overtime hours, trying to work out what went wrong, in embarrassing conversations had with the business to explain why their new lovely all singing, all dancing system burst into flames when it first entered production. Compared to the cost of a virtual RAM chip in a virtual server, I would say once again that even if there were much of a functional performance difference, then it's marginal. And the gains far outstrip any loss you might make in not being entirely as efficient as it could be. The only thing I'd say is that in C#, avoid recursion. Jokes aside, recursion in C# is not very efficient, and if you're not very, very cautious indeed, it will tend to explode your stack. F# has an optimization applied to it, so you can do recursion in F#. This said, the optimization is actually that it converts it into a hidden while loop, because that's fundamentally the only actual way to do recursion is a while loop. So, oops, that's the oh, cheers, Ravi. There's the code again. If anybody wants to contact me on Twitter, I can put the O'Reilly code up as well if anyone wants it. Does anyone have any other questions before we call an end to proceedings?
Yes, I think I do have one question.
Oh, go on then. Just ask a question.
What would be your position regarding using constructors instead of using init in the properties in C#? Because I feel like well, it's two words, you know. Either you'd rather go with properties and you do all properties, and in my opinion, it means that you kind of leak your the object logic outside of it, because people tend to use auto properties instead of putting logics into them, which means that using constructor would force them to actually implement the logic right into the class itself.
This is one of those situations where, for me at least, we've gone more into the art than the science, and it usually boils down to it depends what you're trying to achieve. Personally, this is my personal opinion. I like auto methods, like auto properties. Sorry, auto property. They're clean. They look clean. I like clean looking, tidy code. Forcing someone to supply all of the parameters looks messy, especially when you might have 20, 30 of them. Can get quite unpleasant then. Plus, by forcing it to be parameterized, you're kind of forcing the order in which they're supplied, and potentially making it harder to skip some unless you put optional parameters in later. And I feel like that's too much of an overhead in terms of maintenance compared to auto properties, which are just nice and clean. But the sacrifice you make is, you're right, you lose a little safety in terms of forcing everyone to provide what we need. I'm personally happy with that exchange, but depends what you're trying to do. Depends on your personal coding style. This is one of those where I have to ultimately remain neutral, because I am not a purist, and in fact I'm a C# developer. I can't be pure to the functional paradigm. It is not going to happen. But it's for me, it's more about where do you make the compromise, where do you draw the line and say I'm staying this far. And for me, I'm okay with auto properties. We got a question. Prasad. Which situations will be ideal for functional programming approach to C#, like data processing, parsing? I mean, it can do everything, of course. The rule of thumb is anywhere where there is an interaction with an external system is where it is less, I wouldn't exactly say even preferred, but where you have to put something in to compromise around the purity of the implementation of functional language. So there is an architectural style that goes around. It's functional. What is it? A functional core imperative shell, or possibly the other way around. But the idea is the core in the middle of your system is entirely functional, and then you put a shell around the outside, and this shell represents all interactions with other systems, so files, web APIs, databases, anything that's not literally your code base. Those are the places where you're allowed to put some imperative code to kind of handle these situations. But once we've passed beyond this shell, everything from that point on is purely functional. So all of your business logic should be contained ideally in the functional part of the system. I'm a big advocate for DDD, that is domain-driven design, and that this style supports that well. So I would take it. My style would be that you have database related entities over the database area of the code in the imperative shell, which then converts it to some sort of internal entity, which is understood by the internals of the system, and those are passed in and handled by the entirely functional area of the system. It's like having an airlock, in your spaceship. The airlock is allowed to touch both the functional interior and the imperative exterior, and it's the airlock that makes sure that none of the vacuum of space enters your functional code base, if you see my meaning. So that's how I imagine it anyway. I do another talk where I gave an example of creating a computer game in this, and I kind of put two layers of processing between the external world of the player of the game and the internal world of the game engine. And those two layers were basically filtering out side effect piece by piece until we reach the internal world, which should in theory be completely side effect free. That's how I operate. There's no formal system behind this, but this style works well for me. So I hope that answers your question, Prasad. Any more for any more?
Doesn't
Going
look
once?
like it.
Going twice? Okay, and Salt. Well, thank you very much, everybody. Thank you. It's been lovely to speak to you all, and I hope reach out to me on Twitter if there are any further questions. I am easily bribed with beer when questions are involved. And cheers. I'll stop sharing. I'll leave it to our host to wrap up.
So you can stop the recording.